All right, so let's go ahead and continue here. We're on section 2.5. This section deals specifically with the Lewis dot structures. And so Lewis dot structures is not a very complicated thing overall. We've been doing this for a while, but you still need to know the process overall. And so I'll just quickly go ahead and write those steps here for us and put them on the screen, and that way you can see them all at once. So here is the list that we need to be aware of. So essentially the steps are the following. You want to go ahead and identify the center atom. This is typically going to be the more electropositive atom. There are obviously exceptions, like in the case of water and whatnot, but the center atom is typically the more electronegative. If you have a metal, that's typically going to be the one for you. A quick way of identifying that. Step 2 is to identify the total number of valence electrons. So you want to go ahead and do this by counting the valence electrons for each individual atom first. Remember some of the common things. Group 1 elements have 1 valence electron. Group 2 has 2 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons, and that'll give you the total number there. Now, once you're done identifying the total number of valence electrons for each individual atom, the thing that you want to do is quickly check to see if the molecule that you have has a charge. Now, if it has a charge, it'll be typically be identified on the upper right-hand corner. And if that charge is negative, then you want to take into account the number, not the actual sign, but the number, the value of the charge, otherwise known as the oxidation number. You want to make sure that that number is added to the total electron count total. So that's one thing here. Add electron to the total. So I'm going to specify here. Same thing for the other one. So these values here are extremely important because that it's essentially think of it this way. When you have a negative charge, clearly that molecule has gained electrons and they need to be added to the total because those are now part of that particular structure. If the charge of the molecule happens to be positive, if there is one, then you want to subtract that value from the total because essentially positively charged molecules, they've lost electrons. And so we need to make sure that we take that away from the total count overall. Now, once you go through these first 3 steps, by this point, if you're taking all of this into account, then you're going to have a true total of the overall valence electrons that you can allocate as you start arranging the structures. Then the next thing is that you want to go ahead and combine those atoms. If there's any groupings with parentheses, for example, obviously those atoms are grouped together, but you're going to start from the center atom and start binding outward, drawing essentially a stick model to represent a bond, and you want to allocate the electrons there. When you start setting up the sticks, obviously you need to subtract that first because you already allocate them in terms of a bond. But then once you've done that, then you want to allocate the electrons to the most electronegative atom first. And then make your allocations all the way around. Make sure that you observe the octet rule in all of this. And any remaining electrons, they're going to go to the center atom. And so let's go through a couple of examples here just so that we can see a couple of these. And so let's see what I've got here. I've just got 3 simple little equations or 3 little samples that I want to show you, and then we'll go from there. And so let's move this over to the side. And so what if I have this particular example here? Say that I've got an example of let's see here, H2S. If we're going to go with this structure here, clearly the first thing I'm going to do is count the structure. So hydrogen has 1. There's 2 copies of that, and I want to go ahead and add that to the count for sulfur. Sulfur's in group 16. Minus 10 means that I've got 6 valence electrons there. If I do the math here, this is going to be essentially 2 plus 6, which gives me a total of 8 valence electrons overall for this particular molecule. So go ahead and bond them. Since I know here the hydrogen is going to be less electronegative than the sulfur, the hydrogen would technically be the center atom, but since I've got 2 of them, here's one of those things where you're going to have to put it on the outskirts, and the sulfur is going to be the center atom. It's a lot helpful also if you draw the actual Lewis structures for individual atoms. And so what you'll see here is you'll see that this particular is going to bond there, and then this other one is going to bond here using the representation. Now, if you have this, then you can already see what the structure is going to be here. So I'm going to go ahead and draw it. You're going to get a sulfur atom in the center. We know that it's bonded to a hydrogen on the left as well as on the right, and so we'll do that there. Now I'm going to be a little bit purposeful and tell you that there are electrons at either end of these, so I'll represent those in red. Now, if we did this here, I know that my total count here is 8 valence electrons. I just added 4 of my electrons here, 1, 2, 3, and 4. So I need to take that into account if I'm keeping track here. So that means I've got 4 electrons left. And so those electrons, once I've allocated, the next step, if you're following the sequence of steps here, any remaining electrons have to go to the center atom. So no center atom here is sulfur. So I will allot those electrons to the sulfur. 2 on one side, 2 on the other. And so this here would be the overall structure. Now I want to go ahead and double check for octet. So if you look here, the hydrogen has 2 electrons in its octet, and so essentially that would mean that this is one of the groupings here. And then that's correct. There's an octet there. We look at the other one here for the hydrogen on the other side. That's octet there. Change the colors here just so you can see the overlap here. Notice here the hydrogen or the sulfur. Notice here we've got a total of 8 valence electrons, 2 for this bond, 2 for that bond, 2 down below and 2 above. That gives you a total of 8. So the sulfur is satisfied there with the octet. And so you want to go ahead and do this in terms of the placement of electrons for each individual molecule that you're looking at. And the idea here is that you want to make sure that when you allocate, everybody has that octet overall. Now, if you recall, there was a problem set that we did in this section. There were a total of 20 molecules that we looked at. So I think each class had its own set of problems, 1 through 10 for A day, 11 through 20 for B day. But if you had not had a chance to look at the other problems of the total 20, you might want to take a look at that. All the solutions have been posted online, so make sure you take a look at the solutions and overall look at that as you go through and practice a little bit more problems here. All right, so what I'll do here is I'm going to go ahead and move some of this stuff out of the way. Let's move this over here. We'll take this and move that as well off to the side. I will take off this and delete. Now, one example that I wanted to do is kind of just go through the what if you had a negative charge on any of these molecules. And so I think if you look at some of the problem sets, you'll see that there are a couple of problems there. I'm just going to grab one from that mix and look at this one here. So for example, if I had something like NH2, but I gave it a minus charge. Now I'm going to go through the whole process, identify the center atom here. Since I've got 2 hydrogens, clearly the center atom here is going to be nitrogen. But nitrogen is actually going to be the negative atom here. But what we want to do here is essentially look at valence electrons. I know nitrogen is in group 15, so that means I've got 5 valence electrons there. Hydrogen has 1 valence electron. There's 2 copies of it. Now here's where you're going to want to add the charge associated here with the minus sign. We're going to have to add that here at the very end. So we're going to make sure we add a +1 to that mix there. And that's part of the process over here when we look at the check to see if there's a charge on the molecule. And here we have a negative charge, so we're going to have to add that electron number to the total count, and that's what we've done right here. If this were positively charged, then obviously you're going to have to subtract it, not add. And so here it's a negative charge, so we're going to add it to the mix. And if we do the math overall here, we're wind up all of these numbers here, when you add them up, are going to add up to 8 valence electrons. Okay. And so the overall structure here is going to be a nitrogen bonded to a hydrogen, bonded to a hydrogen. And so that'll give us the 2 there. And we already allocated 4 of them, so that would leave 4 electrons that we would then add to the center atom. And so what we'll do here is we will add them 1, 2, 3, 4. And in doing that, you want to make sure you double check the valence count. So notice here the hydrogen is going to have its 2. Each one of these stick or bonds represented by a line is a 2 electron bond. There's an electron bond over here, so the hydrogen is good on both sides. The nitrogen needs to have its own octet, so we see there's 2 up top, 2 down below, and then 2 on the left and 2 on the right. So it also has the octet. Now, because there is a negative charge associated here, we got to make sure that we actually draw that in. I'm going to put this in gold and represent it with brackets, and then put the negative charge on the outside. In the next section, in 2.6, we look at resonance structures, and we can see that some of these resonance structures will have another way that you can draw them. This one here won't have that, but other structures, especially when you have electronegative atoms like fluorine, when you have oxygen, or when you have nitrogen is another one of those atoms where that double bonding can occur. You can even have triple bonding with that, but it's typically going to be a lot of these electronegative atoms that are pretty high in their electronegativity count. That includes sulfur, that includes nitrogen, oxygen. It's also going to include, in some cases, you'll have carbon forming double bonds as well, as we learned in the last section there in 2.7, which is going to be coming up here pretty soon. So this will be the end for 2.5. We're going to continue this discussion on Lewis dot structures, but now applying the resonance on top of that, and we'll look at that here in 2.6 in the next video.